vector question, so we've got two vector lines. Remember that when you have vector lines, this first one is a point on the line, and this is the direction vector for the line. So it tells you which direction the line's going in, like gradient when you're used to Cartesian. So we are told that these two lines are perpendicular, right angles. Now, what tells us the direction? That's the direction vector, obviously. So we need to look at the direction vectors. The first one is just a point on the line. You can't find an angle between 2 points. That doesn't make sense. So we need to use the direction vectors for this. Remember, you have a little formula for finding the angle between two lines. And this top bit being called the dot or scalar product. Now, cos of 90 is 0 if they're perpendicular, because the cosine of the angle must be 0. That means that this dot product must be 0. I don't need to work out anything else. If the top of that fraction is 0, then cos theta is 0. So using the direction vectors, I'm going to find the scalar or dot product. So here we go. So that's going to be 1 plus 1 plus p. They're perpendicular, so that equals 0. So that tells me that p is -2. Okay, so now I've got, what was p? P was -2. Right, that's all we can find out from this section, so we found the value of p. In the second one, they've told us that point D is the intersection of L1 and L2, and we've got to find Q and the coordinates of D. Let's move that out of our way. Now, because they've told us there's a point of intersection, that means there must exist a point where they intersect, obviously, which means there must be a point where the position vector from the first line is equal to the position vector from the second line. Okay, now that means that the x coordinates must be the same, the y coordinates must be the same, the z coordinates must be the same, so I can split this up. So that's x, y, and z. Right, we've been told these are the this is the point of intersection, so we're not going to need to prove they intersect. So we can use the first equation, just rearranged, and then the last equation, because that doesn't have a q in it. And we can solve those simultaneously to get that for these equations we're going to get that lambda equals -1 and mu equals 4. Once you've found lambda and mu, we can take our other equation which has got q in it and substitute in these values. So q subtract 1 equals -4 plus 4, and from that we can find out that q equals 1. So we've now got the value of q. Once we've got the value of q, we don't want to forget they also want us to find the coordinates of d. So now I've found the values of lambda, mu and q, you can substitute into either line. So you can use R1 or R2 to find d. So for example, R2 gives us 3, -4, -5, plus mu was 4 times 1, 1, 1. So that gives us 7, 0, -1, and they wanted the coordinates of d, so d is at 7, 0, -1. Make sure you write it in coordinate form.